If you drop a metal in an acid, you can see that a lot of hydrogen gas starts evolving. And if you know rocket science, then you can use this hydrogen gas to fuel your own rocket. So in this video, let's see how acids and bases react with metals. So here I have a piece of magnesium metal and I'm going to react it with hydrochloric acid. Now see, in this reaction, magnesium is more reactive than hydrogen. You might be wondering, how do I know that? So basically, scientists have prepared a reactivity series which lists few elements in the order of their reactivity. The higher the element in the list, the more reactive it will be. So over here you can see that magnesium is somewhere over here, somewhere higher, whereas hydrogen is below it, right? So magnesium, since it's higher, is going to be more reactive than hydrogen, and it will displace hydrogen from its chloride and instead form magnesium chloride, and hydrogen gas will be separated out. It will evolve out of the solution. So finally we will have magnesium chloride being formed and hydrogen gas will be separated out. So over here we saw that a metal reacted with an acid to evolve hydrogen gas and leaving behind a salt. And yes, this is a salt. See, salts are made up of ions, and here magnesium chloride is made up of magnesium plus 2 ion and chlorine minus 1 ion. And salts are electrically neutral. So over here magnesium has a charge of plus 2 and each atom of chlorine has a charge of minus 1. So in total chlorine has minus 2 charge. So plus 2 minus 2 makes it 0 or electrically neutral. Now some of you might be wondering, Ram, why isn't HCl a salt? Why is it called an acid? Because I know that HCl is also made up of ions. It gives H plus ion and chlorine minus ion. So see, pure HCl is not made up of ions. In fact, there is a covalent bond between hydrogen and chlorine. And don't worry if you do not know about covalent bonds right now. We will talk about that in a later video. But yes, pure HCl does not have ions in it. Only when it is mixed with water, it breaks into ions, H plus ion and chlorine minus ion. Whereas MgCl2 over here will always be in the form of ions. Now let's look at another example of a metal reacting with an acid. So this time I have zinc metal and I'm going to react that with hydrochloric acid. Now can you pause the video and think about what the products are going to be for this reaction? Now if you have given it a try, let's see. So here I will again use the reactivity series. I can see that zinc is somewhere here, whereas hydrogen is somewhere below. That means since zinc is above, it is going to be more reactive than hydrogen, right? That means zinc will displace hydrogen from its chloride and form zinc chloride, and hydrogen gas will be evolved out over here. So the products will be zinc chloride, which is a salt, and hydrogen gas will be evolved. Now let's look at the same reaction in an actual chemical experiment. So when you put zinc metal in hydrochloric acid, you can notice that there are some bubbles evolving. Now whenever there are bubbles evolving in a liquid solution, that means a gas is being formed and that is trying to escape out of the solution. And we have seen in our chemical reactions that this gas is going to be hydrogen gas. But how do I verify that experimentally? Because see, this gas does not have any color and it does not have any smell also. And we know that there are many gases that are odorless and colorless, like oxygen, carbon dioxide, or nitrogen. All of these gases are around us in the atmosphere, right? And these are also colorless and odorless. So how do we experimentally verify that this gas is hydrogen gas? So for this, we are going to perform a test, the pop sound test. So for this, I'm going to transfer the hydrogen gas in a separate test tube. See, this part of the experiment could be very dangerous. So always perform this in the presence of an expert, okay? Now I'm going to bring a lit matchstick close to the mouth of this test tube and the hydrogen gas will burn and you will notice a pop sound. Did you hear that? Listen to it again. So hydrogen gas burns over here with a pop sound, and this is unique to hydrogen. No other gas will burn giving a pop sound. So a pop sound identifies the presence of hydrogen gas. Now some of you might be wondering, Ram, why does hydrogen burn with a pop sound? Like what's special over here? So let me tell you a little bit in detail. So see, hydrogen gas is highly inflammable. So when it burns, it reacts very quickly with the oxygen gas. It combines with the oxygen gas to form water. And we have seen earlier that combination reactions in general are exothermic. They give out heat. In fact, this reaction gives out a lot of heat. A lot of heat is being generated. And this heat heats up the air that is inside this test tube. And this heated up air, it starts expanding very rapidly. Now this air has nowhere to go but the mouth of the test tube, right? So this expanding air, it rapidly goes towards the mouth of the air, where it meets the stationary air that is outside of the test tube. And then these two air collide, and that is when we hear the pop sound. So this is like a mini explosion, but many more things are happening in detail over here. And to understand them, you will have to study about the physics of sound and sonic boom, which we will talk about later. Let's now come back to chemistry for now. So far we have seen that when metals react with acid, we get a salt and hydrogen gas is released. So I can say that in general, metals react with acid to give salt and hydrogen gas. And the reason why I'm writing in general is because not all acids react with the metals to give out hydrogen gas. For example, if you take HNO3, nitric acid, it will not react with all the metal to give out hydrogen gas. That's why, to be on the safer side, I'm writing in general over here. Okay? And if you're wondering about why this happens, then don't worry about that right now. We will talk about this later in a separate video. Now let's see how bases react with metal. So in general, metal and bases, they do not react to give us salt and hydrogen gas. Yes, in general, metal and bases, they do not react to give us salt and hydrogen gas. But there are some exceptions, like the metal zinc. It reacts with a base. It will react with sodium hydroxide to give us salt and release hydrogen gas. For example, the products in this case will be sodium zincate, which has a very weird chemical formula, Na2ZnO2. And with this, hydrogen gas is released. So yes, there are a very few metals that will react with a base to give us salt and release hydrogen gas. Now with this, let's summarize the video. In this video, we saw what products